So the next topic is the module 4 of your basic electronics, which consists of analog and digital communication. Okay, so it starts off with modern communication system, different types of communication system, then it goes on to the modulation, then digital communication, radio signal transmission, multiple access techniques, then antennas. These are the important topics which you have in your module 4. Okay, so this unit deals with communication. Okay, so communication, what is meant by communication? So communication is nothing but transmission of information, right, from the source to the destination. So you will be having an information source and destination. Now what is the role of communication system here? Okay, the communication forms a link between, so communication system forms a link between the source and the destination. Okay, so if I want to transmit some data from the source to the destination, there will be some system. So that system is called as your communication system. So what is meant by communication engineering? Communication engineering can be defined as an electrical communication in which information is transmitted through electrical signals. Okay, so now I am speaking or I am giving a lecture. Now I am the information source. Okay, my information has to be converted into an electrical signal so that it can be transmitted to the destination. So what is meant by an electrical signal? Electrical signal is nothing but your any time varying electrical signal. Okay, any time varying voltage, current or EM waves, right? Electromagnetic waves that carries the information. So the information from the information source has to be converted into an electrical signal. That is called as communication engineering. Now what is electrical communication? So electrical communication can be defined as a process by which the information or message is transmitted from one point to another, or from one person to another person, or from one place to another in the form of electrical signal through some communication link. Okay, so as I have mentioned before, the information between the information and the destination, who forms the link? The communication system forms the link. This communication system consists of various units. Okay, these units can be also called by another name. It can be called by constituents or subsystems or different stages. Okay, so what are the different stages of the communication system? The basic communication system consists of various stages. So you will be having an information source. Okay, from the source, the message will be given to the information or the input transducer. The output of the transducer will be given to the transmitter. The output of the transmitter will be passed through the channel in which the noise will be added, and the information passes through the channel, and the next stage will be your receiver. The output of the receiver, you have to separate your message signal, right? So you will be giving it to the output transducer, and the original message will be given to your final destination. This is the basic block diagram of your communication system. So let me now explain what is happening in your different blocks with an overall idea. So information source, for example, now I am speaking, so I am the information source from where the message or information is being originated. Okay, so it is nothing but the output of the information source is nothing but your message. Now this message will be given to the next stage, that is called as your input transducer, information or input transducer. So what is the use of this transducer? The transducer converts the physical information to electrical signal. So it is called by many names. Okay, it is called as your baseband signal or message signal or information signal. Okay, so this electrical signal, what is the output of the transducer, will be given to the next stage, that is your transmitter. Okay, for example, imagine that you are going for a function. from one state to another. Imagine that you are going from Bengaluru to Bombay. Okay, so what will you do? You have to reach the next day. Since it is very difficult to walk or reach the destination in the stipulated amount of time, let us assume that you are choosing airways. Okay, so in the case of airways, you will be doing all your packing, and then you will go to the airport, and you will be seeing many passengers similar to you who wants to go to the particular destination. So there should be a carrier who will carry all those message signal, okay, all those passengers. So now in this case, the carrier is your aeroplane, where the capacity of the carrier should be high than that of the message signal or the passengers. Okay, so just similar to that, in the case of communication system, the message signal should be able to transmit to the destination by a high frequency signal, that is called as your carrier signal. Now the carrier signal will carry all your message signals simultaneously, because the best example is the telephone, right? Wireless telephone, you have millions and billions of people calling to different destination at the same time. So similar to this, the transmitter, what this transmitter does is, before the signal is passed through the channel, the transmitter will modulate the signal by means of a high frequency carrier wave. That is, the carrier wave will be carrying the message signal. Okay, so that process is called as modulation. So after modulation, the transmitted signal which is obtained is taken as x of t, which will be given to the channel. Okay, so the channel may be wired or wireless. For example, if it is a long distance communication, the channel may be air. Okay, so in the case of the example of airways, the channel or medium was the air, right? Free space. So as the signal passes through the channel, the noise will be interfered with the signal. Okay. Now the signal along with the noise will reach the receiver. Once it reaches the receiver, output of the receiver is taken again as S of t, because in the receiver the baseband signal or the message has to be separated from the carrier signal, right? Just like that, after you have reached your airport, in the receiver side, you have to go to your, all the passengers has to disperse to their respective destination. So now it will be separate, you will get your baggage. Just similar to that, then all the message signal will be separated from the carrier signal, and it will be given to the output transducer, where you are going to get the original message signal to the final destination. So what is the role of your output transducer? It will again convert your electrical signal into your message signal, into your information. Okay, so this is your basic block diagram of your communication system. So now we are going to see the important points of these different blocks or information source, transducer, transmitter, etc. separately. Okay, so the first stage in the communication system is the information source. Okay, so information source and the input transducer. First two parts. Okay, I am taking it together. Okay, so in this case, what is meant by information source? So the information source consists of the physical form of information, right? Which is nothing but your message. Or the information source is that stage from which your message is being originated. So this message will be originated from the information source. Okay. Now, what is the function of your transducer? Transducer is used to convert the information to electrical signal. Okay. So the information will be converted into electrical signal. So in this case, now I am speaking. So the sentence what I am talking will be your message. Sentence will be the message. And who is the information source? I am the information source. The information source will be the person. Okay, this is one example. Okay, now let us come to the transducer, which converts the information into your electrical signal. So this electrical signal can be called by different names. Okay, so it can be called by baseband signal, or it can be called as message signal. MSG is for message. Okay, or it can be called as information signal. It can be called by different names. Okay, so different textbook has different names. Or it can be called as intelligent signal, or it can also be called as envelope. So totally it has 1, 2, 3, 4, 5 different names. Okay, and here in this block diagram it is represented as S of t. Okay, so the baseband signal is equal to S of t. Now this baseband signal can be divided into two types. So what is your first type? First type is called as analog signal, and the second one is called as digital signal. So now what is meant by analog signal? If it is a function of time, continuous signal, right? If it is a function of time and has continuous range of values So the example is, if I give a graph function value, and if this is t, so this is f of t, pure sine wave. Now this will be your analog signal, example of an analog signal. Whereas in the case of digital signal, it is not continuous, it is discrete in nature. Okay, discrete in nature. Now what will be your example? Example, at different instant of time, only at different instant of time you will be getting the values t3, t4, t5. So this is time function value. So here only at particular instant of time you will be getting the signal. Okay, other time your signal can be 0 or a different value. Okay, so this analog signal can be converted into digital signal by means of two processes. One is called as sampling and the other one is called as quantization. So what is meant by sampling? Sampling means if the analog signal time, continuous time, is converted into discrete in time, converted to discrete, then it is called as sampling. Okay, that is, in this case, what is the x-axis? If your x-axis is in time, then it is called as sampling. Discrete time, then it is called as sampling. Now what is meant by quantization? If your y-axis, that is the amplitude, the continuous amplitude, or the continuous amplitude is converted to discrete amplitude, then it is called as quantization. Okay, quantization. So in this case, what is the value? It is in the y-axis. So this will be your, if both are your discrete value, then it is called as a digital signal. Whereas discrete meaning is only if the time is in discrete, then it is called as, the function value is continuous, and if the time is in discrete, then it is called as discrete. So don't confuse about the digital and discrete. Digital signal means both the x and y axis will be discrete in nature. Now the process of sampling and quantization together will be called as analog to digital conversion. Okay, and the stages or the equipments which does the analog to digital conversion is called as analog to digital converter. Okay, so this is all for your first stage, that is your information or your input transducer. Now the second stage is going to be your transmitter. Okay, so this will be your first stage. The second stage is called as your transmitter. So the main process of modulation is being done in the transmitter, as we have seen before. The processing of the baseband signal. So what does it does? The transmitter does the processing of your baseband signal or your processing of your SOFT. Now this processing can be in two different types. Okay, types of processing can be two different types. So what is your first processing type? You are converting the low frequency signal into a high frequency signal. Frequency to high frequency. That is your first processing. Second one, you are not converting into a high frequency signal. That is the baseband signal without translation. Translation to high frequency. So without translation. So the first type is called as carrier communication system. Carrier communication system, and the second type is called as baseband communication system. Baseband communication system. So the first type is called as carrier communication system and the second type is called as baseband communication system. Now we will see what is meant by these two systems separately. So in the case of carrier communication system, so carrier communication system and the second one was your baseband communication system, right? So in the case of carrier communication system, your low frequency signal was converted into a high frequency signal. Okay, so this process is also called as modulation, where your low frequency message signal was superimposed onto a high frequency carrier signal, right? So the diagram is given by, so if this is your baseband signal, okay, input baseband signal, so S of T. In the case of carrier communication system, it will undergo certain different process. So this will be your modulation stage. Modulation stage. So in the modulation stage, what is your another input? Another input is going to be your carrier signal. Okay, C of T. It is given as C of T. Now what will be the output of this? The output will be your modulated signal. The modulated signal, which is given as X of T. X of T will be going on to the next stage, that is the voltage amplifier stage, and the next one is your power amplifier stage. Voltage amplifier and power amplifier stage. Output of the power amplifier will go to your channel. Okay, so to channel. So this is your diagram. So what will be your this section? Voltage amplifier and your power amplifier will be your amplifier section. Okay, and this complete stage is going to be your transmitter. Transmitter will be a combination of modulation as well as your amplification. Okay, So this will be your basic block diagram of your carrier communication system. The baseband signal will be given to your, first it will be modulated along with your carrier signal. Modulated signal will be given to your amplifier, that is which amplifies the amplitude as well as the power of the signal, so that it can reach the receiver through the channel. Okay. Now this carrier communication system can be again divided into two types. Okay. One is just similar to the previous type. One is called as your analog and the second one is your digital. Okay. So what is the what may be your analog type carrier communication system? If the baseband is analog, if the baseband signal or the message signal is analog, then it is called as analog communication system, and it uses analog modulation methods. Okay, the various analog modulation methods are amplitude modulation, frequency modulation, phase modulation. Okay, similar to that, what will be your digital communication system? So what will be your digital? If the baseband signal is digital in nature, that is discrete both in time as well as function, then it is called as, then it comes under the category of the digital carrier communication system, and it uses digital modulation techniques. Digital modulation techniques. Okay. So these are the major two differences of your carrier communication system, analog and digital, different types of modulation. Now the next one was your baseband communication system, right? So in the case of baseband communication system, your message signal was not converted into a high frequency signal. So in this case, what happened? Let me draw the diagram once again. So this will be your message signal. If it is, this is for the case of analog. Okay, low frequency signal, S of t, baseband signal S of t. What was your carrier signal? High frequency signal, right? High frequency signal consists of more number of cycles. So this was your carrier signal. So based on whether amplitude is changed or frequency is changed or phase is changed, it will be modulated. But whereas in the case of baseband communication system, you are not going to convert your message signal into a high frequency signal, but some form of processing is needed before the transmission. So one of the example is two different range of frequencies can be used. Suppose if this is your baseband signal S of t, okay, which has two different, if I take this as time, so low and high value, low, high. This baseband signal, suppose if this is equal to T1, T2, time period it is high, again T1 it is low. So it takes two different values. It can be transmitted or it can be transformed into a processed signal that consists of two different range of frequencies. So low means it can be denoted by low frequency signal. Okay, so this will be coming under the category of low frequency F1, which is low frequency, two range of signals. Okay, F2 will be high frequency. So low frequency means you will be getting less number of turns. Okay, high frequency means you will be getting more number of turns. Similarly here also low frequency, high frequency signal. So this is how you can represent your or you can process your signal in the case of baseband communication system. So this processed signal will be transmitted to the next stage, that is your channel or medium. So before the next topic, channel or medium, so for example for long distance communication, the signal which is used is called as your radio signals, right? Radio signals. So what is meant by radio signals? Radio signals are transmitted through electromagnetic waves, right? It is transmitted through electromagnetic waves. So it is also called as radio waves. Okay, it's also called by another name, that is called as radio waves. What is the extension? It can range is from few 10 kilohertz to several thousand megahertz. Okay, so this wide range of frequencies is also called as radio frequencies. Okay, radio frequency. So it is usually mentioned in terms of RF spectrum, radio frequency spectrum. Okay, so this RF spectrum will be classified according to the applications of the spectrum in different service areas. So this is the table for the different RF spectrum. Mainly it is classified into 7 different sections. Very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency and super high frequency. Okay. So the RF range, wavelength and applications are given. So for very low frequency, the range is from 10 to 30 kilohertz. And for low frequency it is 30 to 300 kilohertz. For medium frequency it is 300 to 3000 kilohertz. So 3 to 3000 megahertz will be your high frequency. 30 to 300 megahertz will be your very high frequency. 300 to 3000 will be your ultra high frequency, and 3000 to 30,000 megahertz will be your super high frequency. Okay. So this is all about your RF spectrum. The next section what you're going to see is your channel or medium. Okay. So channel or medium. So what is meant by channel or medium? Okay. So if you see your block diagram, okay, the transmission medium between the transmitter and the receiver is called the channel. Okay. So in this case, most of the noise is added in the channel. It doesn't mean that the other noise, there are no other noises in other blocks. There are noises, but compared to the noise in the channel, all other noises in all other blocks are very small. Okay. So this is a very important factor which has to be reduced. Okay. So there are mainly 3 factors which affects the, okay, 3 factors that affect the channel characteristics, that affect the channel characteristics. So the 3 factors that affect the channel characteristics are, one is your transmitting power, second one is your bandwidth, and third one is the cost of the communication system what you use. Okay, so these 3 factors will affect the channel characteristics. Okay, so based on the physical implementation, so based on the, or depending on the physical implementation, this channel can be mainly divided into 2 different types. So the 2 different types. So what are the 2 different types? So one is called as your hardware channel, and the second one is going to be your software channels. Okay, so what is meant by hardware and what is meant by software channel? So hardware channel is nothing but your man-made structures. Okay, man-made structures, and always there will be a physical link between the transmitter and the receiver. There will be a physical link between transmitter and receiver. Okay, so mainly there are 3 different types on depending on the implementation. So classification of your hardware channel, it is again divided into 3 different types. So 1, 2, 3. So based on the implementation, it can be divided into transmission lines, Second one is your waveguides, and the third one is going to be a optical fiber cable. So 3 different types. So what is meant by transmission lines? Okay, transmission line, the example is equal to twisted pair cable, and coaxial cable. Okay, so the next one will be your waveguides. Waveguides, here the transmission lines is not suitable for ultra high frequencies, whereas your waveguides is suitable for ultra high frequencies. So what is meant by waveguide is a hollow metallic structure. Okay, it is circular or rectangular in shape. So it's a hollow metallic structure. Okay, so here what happens, the signal enters the waveguides and reflects the wall and propagates to the other side of your waveguide. Okay, this is how your high frequency signal passes towards your through your waveguides. The next type of your hardware channel is your OFC, or your optical fiber cable, which is very highly used, right? So it is nothing but thin circular pipes, hair-like structure. Okay, so it transmits the signal in the form of light energy. Okay, so these are your important points in your hardware channel. Now, whereas in the case of software channel, and one more important thing, the signals which utilizes this type of hardware channels is called as line communication system. So it is called as line communication system. Okay, so in the case of software channels, it is opposite of your hardware channel. There will be no physical link between the transmitter and the receiver. Okay, so what may be your example? There is no physical link means it is wireless, right? So the main example is air or open space and sea water. Okay, now the signals will be propagated by means of EM waves or electromagnetic wave called the radio waves in the case of wireless communication. Okay, so signal transmits in the speed of the light, where c is equal to 3 into 10 raised to 8 meter per second. Okay, so what is happening in this type is there will be a transmitting antenna to transmit the signal, and in the receiver there will be a receiving antenna which will accept the signal. Okay, so the system that uses this radio waves for transmission is called as radio communication. So it is also called as radio communication. Okay, so what may be the example of your radio communication? Example are your radio, TV, right, satellite, and cellular communication. Okay, so these are the different important points which you have in your channel or medium. So the next topic that you are going to study is your noise. So what is meant by the noise? The next input to the channel is called as your noise wave. So what is meant by noise? The noise is the electrical disturbance that does not contain the information, right? It does not contain information. It's a disturbance. Okay, so if noise is very high, then what happens to your signal? Signal will be suppressed, or signal will be less. Okay, the noise will be dominating. Therefore, always the power of the signal should be very, very high compared to that of your noise. Okay, so that is, the signal to noise ratio should be very high. Okay, only then your signal can be recovered at the receiver. Okay, so the noise introduced by the transmission medium is called as external noise. Okay, external noise and internal noise. So what is meant by external noise? External noise is the noise which is introduced by the transmission medium. Okay, transmission medium noise. Whereas what may be your internal noise? The internal noise may be caused due to the thermal agitation of atoms and electrons. Where? Inside the equipments. Electrons inside the electronic equipments. Okay. So there are very two important factors. One is called as your signal to noise ratio and the second one is called as your noise figure. Okay. Signal to noise ratio. So first let us see what is the signal to noise ratio. So what is meant by signal to noise ratio? It is defined as the ratio between the signal power to the noise power. Okay, so if your signal power is taken as PS and noise power is taken as PN, so what is your signal to noise ratio? I can write that signal to noise ratio is equal to PS divided by PN. Okay, now let us take this as equation 1. Okay, so you know that the power is equal to voltage into current, right? So power of the signal will be equal to signal voltage into your current. So you know that current is equal to V is equal to IR. So current is equal to V by R. So you will be getting Vs into Vs divided by R. So I am taking common resistor. Okay. So you will be getting Vs square divided by R. Now similarly, if you substitute for P and noise power can be given as voltage into current, noise voltage. So you can get write it as Vn square divided by R. Okay, we are assuming that the resistor is same. Okay, both the signal and the noise powers are dissipated in the same resistor R. So that is the reason why I have taken both as R. Okay, so now when we substitute in equation 1, so what you will be getting, S by N is equal to PS is equal to Vs square divided by R divided by Vn square divided by R. Right, so this R will get cancelled, so you will be getting Vs square divided by Vn square. So this is your signal to noise ratio. Now what will be your signal to noise ratio in decibels? In decibels will be equal to power, right? So it is 10 log Vs square divided by Vn square. So what will be your value here? You can take it as whole square. So log them. So you will be getting 2 into 10. That is 20 log Vs square divided by Vn square. So this is your signal to noise ratio in dB. Okay. Now next one is called as your noise figure. Noise figure, which is represented by capital F. So what is meant by noise figure? The noise figure is defined as the measure of the noise introduced by the circuit. Okay, amount of noise introduced by the circuit. So it can be given as the ratio of signal to noise power at the input of the circuit. Input of circuit divided by signal to noise power at the output of the circuit. Output of the circuit. Okay, so this is your noise figure. So if F is equal to 1, what is the meaning? That is, the noise will be approximately equal to 0, right? The output will be having the noise which will be approximately equal to 0, so that the signal to noise ratio at the input and the output will be same. That's why you will be getting F is equal to 1. Okay. So the next stage is your receiver. The receiver receives the signal along with the noise, right? So you will be getting the transmitted signal x of t plus your noise in the receiver side. Okay, so the receiver mainly has two functions. So what are the two functions? The first function is to separate the noise, from the signal, right? And the second one is to recover the baseband signal. Baseband signal. Okay. So in general, the block diagram of the receiver is given by, so this will be your R of t, the section R of t, which is nothing but equal to x of t plus n of t. Received signal. So received signal. So there are different blocks in the processing of your received signal. So the first block will be your front end voltage amplifier. Okay. So front end voltage amplifier. Then the amplified signal R of t will be given to your demodulator. Just the opposite of your transmitter. The transmitter, it was modulation, here it is demodulation. Okay. Now demodulated means the separation of your baseband from your carrier in the case of carrier communication, right? Now you will be getting S of t, that is nothing but your recovered baseband signal. It will be given to the last stage, that is nothing but before giving it to the destination or the output transducer, it will be given to your voltage amplifier and power amplifier, just like that of your transmitter side, in order to strengthen the power of the transmitted signal. So here you will be getting your original signal, that is by applying it to the output transducer, which converts your electrical signal into its original form, and you will be giving it to the final destination. Okay. So before it given to the transducer, it will undergo this amplifier stage in order to increase the signal power. Okay, so that you can recover or you can get the original signal without any distortion. Okay, this is your major overall diagram of your receiver section. So there is one more concept that is called as multiplexing. So what is meant by multiplexing? Multiplexing is the process in which it allows more than one signal to transmit through the single channel. So multiple signals. Simultaneously you can transmit multiple signals through a single channel. Okay. So for example, in the transmitter side you have many number of, there are best example is your telephone, right? You have thousands and billions of people speaking together at the same time. So how can you if I take this as M1, M2, these are the different message signals. So all the message signal can be allotted. There are different types of multiplexing like time division multiplexing, frequency division multiplexing, etc., where you will be combining all the messages into different frequencies or different time slot. For example, in the carrier frequency, you will be allotting each message signal with different frequency, high frequency. If I take this as F1, F2, etc., all the signals will be transmitted through a common channel simultaneously, and in the receiver side all the signals will be separated. Okay, so this is possible. So this multiplexing is possible only when there is a process called modulation. Okay, so this is your concept of your multiplexing. And you have one more small topic that is called as your types of communication system. So what are the different types of communication systems? Okay, so the communication system can be broadly classified based on two categories, based on physical infrastructure and specifications of the signals they transmit, and signal specification of the signal. So based on these two criteria, your communication systems can be divided into different types. Okay, so what is meant by physical infrastructure? Physical infrastructure denotes the channel which is being used or preferred, whether it is a hardware or software design. Okay, and your hardware design. And what is meant by signal specification? It depends on the nature and type of transmitted signal. Okay, nature and the type of transmitted signal. So based on the physical infrastructure, mainly it is classified into line communication system. It is called as line communication system. So under line communication system, what may be the two different types? The two different types is, one is line or radio communication system, and the second one is called as simplex or duplex system. So it comes under the category of, it selects any one, either it can be line, simplex or radio duplex. Okay, so what is meant by line communication? You know that there is a physical link between the transmitter and the receiver. What is meant by radio communication? It is nothing but your wireless. Okay, yeah, your channel can be your free space, air or your seawater. So what is meant by simplex and duplex? So simplex is nothing but it is called as one-way communication system. Example is television. Whereas your duplex, you will be having two-way communication system. Example is telephone. Okay. One more subdivision of duplex is called as half duplex. So mainly your physical infrastructure comes under the category of any of these two different types. Okay. On the specification, based on the specification of the signal, you can mainly classify into two different types. One is your depending on your baseband signal, and depending on your transmitted signal. Okay, so depending on the baseband signal, it can be classified into either analog or digital. And transmitted signal, based on the transmitted signal, either it can be baseband communication system. What may be the other type? Carrier communication system. So mainly your specification of signal or signal specification classification can be four different types. Either it can be analog, digital or baseband communication system or carrier communication system. Okay, so this is your first part of your module 3. So the notes are available in my Telegram channel. Okay.